Okay, finally, now that we have the level, so to speak, we can add the player's character, which is just going to be the blocks that they can control. And we'll add the camera, and we'll actually start getting some gameplay input functionality working. So let's add an instance of this grid blueprint to the world. Oh, this is interesting. Root of the blueprint is not the root of the grid. Now, you may have figured out the reason for this issue. I believe it has to do with the transform scaling the child components relative to a empty blank scene root is causing this weird scaling issue with the translations being scaled in some way. So if I move this guy, the child components move 10 times faster or whatever. So that's an issue, but we could try to solve this, but there is a workaround. If we just move the root component of our grid to the origin of the scene, so 0, 0, 0 in world space, then the alignment is correct. So we can just, we had to pick somewhere for this to go anyway. We might as well just not worry about it and use that, let that decide for us. So now that's going to be where the grid is located, and we'll position everything else around it. Since we're not going to be, moving the camera around or moving objects around the world dynamically like that, this will be fine. I think it's fine to just have this be 0, 0, 0. And then, we spawn our character blocks relative to the world space origin. It makes sense anyway to have the grid oriented there. I think that's fine. So that's how we're going to do it. And now let's add a camera. So I'm just going to add a camera statically into the world. And we will rotate it so that it is looking down the world y-axis. And let's see, we need to add a light source so that it can actually see things. So I'm just going to start with a directional light and see how that looks. Let's orient it a little better than that. Now, one other consideration we need to make, or one of several other considerations we need to make, is obviously the location of the camera is important. Let's figure that out first. So if these are 100 units apart, then we want this to be focused on the center of the grid, maybe offset by a little bit to make room for, UI elements on the actual game screen. So for now, let's get the center of the grid, which would be, I believe, 800 across and 1000 or 500 up. And then if we pull back, let's see if that looks centered in the preview here. It's basically centered, I think. It's not centered at all. That's because I didn't change the Z value. I changed the wrong value, so this should be 500. There we go. Now the top and bottom come into focus at the same time. Perfect. Well, not perfect, but that's good. So one consideration we need to make is whether to have a perspective camera or a orthogonal or orthographic projection. So if we have perspective, that means those, the world will look 3D and the edges of the camera will be, things around the edge of the camera are going to appear like curved because it's going to be like the camera is a curved lens. So if we want this to kind of look flat in 2D but not be actually flat, if we pick orthographic projection, it will be perfectly flat, and maybe that's what we want. So we just need to change the width here to zoom out. Basically, we can see how that looks by pressing play. Actually, no, we have to go to this specific instances settings and press auto activate player 0. What we need to do is change the game settings, which we'll do in a moment. But this could work. We can try this out. It'll look like truly flat, which could be fine. But if we want to give it some 3D, what we would do is use a perspective projection and then just do a really low field of view. But even that will have some weird curvature, which can make the columns look, uneven. So perhaps we'll stick with orthographic for now and see if we run into any problems, and if not, perhaps we'll keep it. There's some weird optical illusions where columns look not the same length, but I think that's just an optical illusion. So what we should do before we forget is to go up to project settings, go to maps and modes, and first of all, let's actually save this level as I'm just going to make a folder called levels, which there will probably only be one, and I'm just going to call this map main level. Very creative. And now let's just save everything, go back to project settings, maps and modes, and pick the default level in the game to start up as main level, and editor startup as main level. And okay, so for the game mode, we can use the game mode or a game state object, but we can go ahead and use the game mode object in this case to house like global variables, like perhaps the score, which will be used by the UI as well as the game logic itself. So we'll go ahead and put some global variables in the game mode. So now that we've changed the default level to be this new level we've created, let's make a game mode blueprint inheriting from the game mode base that was created when we created the project. So let's go ahead and make a blueprint. Just call it LPP game mode blueprint. You can call it whatever you want. I try to keep names descriptive but not overly long. And here's where we'll set up the defaults for the player controller class and the pawn and everything else. So for the player controller, let's go ahead and actually make a new player controller class. Just call it LPP player controller, I guess. Now, as usual, this will take a minute or two to compile the new C++ files. Alright, that wasn't overly long. And now let's make a blueprint based on that. Just put it in the root for now. The root of the content folder, that is. Now, it appends my to the blueprint version of it. I'm just going to rename it to LPP underscore player controller underscore BP. It's getting a bit messy, but that's about the limit of how long I want my object actors and blueprints to be. But now in our game mode blueprint, in the blueprint that inherited from the game mode class, we're going to just change some of the values so that the player controller is the one that we just created. And we don't need a default pawn because the game is going to begin without any pawns in the game, and we're going to spawn them in at runtime. So now that we have that initially set up, let's go to the world settings for this specific map and set the game mode override to the game mode blueprint that we've created, just to ensure that it will always run correctly. And we might as well go to the project settings, maps and modes, and also ensure that the default game mode is the game mode blueprint that we just created, so that whether it uses the default or overrides it, it's going to be the correct one. And so that's the camera in the correct position. The player controller will spawn in an instance of the player controller. See, it spawns in at runtime. So we can use the player controller to, receive input. So we'll work on that now. Now let's add some input bindings. I've expanded the viewport slightly by shrinking the left and right sides of these menus a little bit so I can see the game screen a little bigger. So let's go to the project settings. Go down to input here, and then we can add some action bindings. So if you're unfamiliar with Lumines, let me bring up this screenshot from GameZebo. Here is the blocks that the player can control. I'm going to refer to this as the quad. This is the quad that the player controls, which is 4 blocks in a 2x2 formation. And then the player can move the blocks left and right by 1 column at a time, and then they can choose to drop the blocks more quickly, and then they can rotate clockwise and counterclockwise to move the blocks to the position that they want before they drop it in. So I'm going to refer to this as the quad, and then the player can move left and right, and they can rotate clockwise and rotate counterclockwise, and they can move down, and they can also drop. So you can press the move down button once to move down 1 row quickly. It also drops by itself over time, just like Tetris. But you can choose to drop more quickly, or you can choose to drop immediately down to the bottom by pressing another button. So there's a separate button for 1 increment down, and then there's an additional button for all the way down instantly. So we'll go ahead and add some of those input bindings now. So, oops. If you have a gamepad, like a Xbox controller or a PlayStation controller hooked up to your PC, you can bind those as well. I'm going to start with just keyboard bindings. It's up to you how you choose to lay these out, but I'm going to, first I'll call this move left, and I'm going to use the W or the A key, the WASD keys for movement, and the left and right arrows for rotation. So, and I'll go ahead and bind the gamepad controls too. But I'm going to do the keyboard first for now. So this will be the A key. So I'm just going to type keyboard. Or no, I'm not. I'm going to type just the letter A, I suppose. And then I'll scroll down until I find the A key. Move right. And I'll use the D key for that. Oh, hello. Move down 1 space. And then I'll call drop the action to move all the way down immediately. And then I will also create one more binding called drop, which will be the immediate down. I'm going to bind that to spacebar. And two more. One for rotation, let's say counterclockwise. CCW counterclockwise. And I'll do that with the left arrow, or arrow key left. Let's see, left. And then rotate clockwise. Oops. That will be the right arrow, obviously. Everything here is digital. There's no axes because we're just going to have completely binary movements. I've connected an Xbox 360 controller, so I can go ahead and bind those now too. For testing, it's more convenient to use the keyboard, but I think for gameplay, I intend to use the game controller, so it's more enjoyable that way. Again, these bindings are up to you. I'm going to say left stick left for moving left. And then left thumbstick right for moving right. Let's see, for moving down, I guess I'll say left stick down. And then for dropping, probably one of the bumpers would feel most intuitive for that. Shoulder buttons, yeah, so gamepad, right shoulder. And then that would be like R1, I guess, on a PlayStation controller. And then to rotate, so I believe on the PSP, which is the only Lumines game that I've played, I believe it's like you can configure which of the face buttons you want to rotate. But what feels right to me is to have the left face button, so that's the X on a 360 controller. I think that's square on a PlayStation controller. That's to rotate counterclockwise. So yes, let's get to that then. Rotate counterclockwise. I will use the face left. And then to rotate clockwise, I will use face right. Or sorry, face down. Face bottom. So again, that's the A button on the 360 controller or the cross on the PlayStation controller. For me, that just feels like the most common buttons to use are A and X. So in order for the player to see their actions take place, we can just print out some console, or we can just print string to the screen. But I'm relatively confident that input bindings will work, so we don't need to worry about printing that. We just need to create the quad object so that there's actually cubes on screen that the player can control. So let's start by one more time making I think the quad can exist on screen without a separate class. All we're going to need is a class for an individual block that will take up one of these grid spaces and that appear in a group of 4 at the top. So let's make one class called just call it block. I think that will be clear enough. So it's just an actor. It could be a pawn, but I think an actor will be fine. So let's make a block. And now that the block class has been created, let's make a child blueprint and just call it block_BP. And we'll put it here. Soon enough we'll organize our blueprints, but for now I think it's fine with only having 3 of them in there. Or 4, who's counting anyway. So we'll go ahead and make the cube the root. We don't need to have a separate root, so we'll add a static mesh. Just call it block mesh. And use the cube. So if we left click and drag the block mesh onto the scene root, it'll replace and make the block mesh the new root of the object. And now we need to add some materials so that it looks kind of like the cubes in Lumines. There are many color schemes in Lumines, but the default one is a sort of silver color for one of the blocks and orange for the other blocks. There's always only 2 block colors in Lumines, depending on which color theme is currently playing on that stage. But so let's go ahead and make some materials. Why don't we make a subfolder within static mesh and call it materials. And then we'll right click here and create a new material and just call it block color 1. And then we'll have block color 2. Actually, we'll have block color 0 and block color 1. We might as well stick with that convention since we're probably going to be using that convention within the logic of the blueprints. We should have a 0 indexed numbering scheme. So I'll rename this to block color 0 so I don't forget. Okay. So if you hold down V and then left click somewhere in this graph, it will create a vector parameter. And then we can make a color here by double clicking and picking a color on the swatch. I'm going to go with the orange color first, arbitrarily. I am definitely not a graphic designer, so I don't really know what color of orange looks good here. I'm just going to pick that one and take the main parameter and put it in the base of the output node. And that's not red enough, I think. Perhaps that's better. We'll see. And we'll leave these alone for now. We'll probably change them later. But for now, we'll just save that. What we should probably do is set up material instances in the near future so that we can make changes more rapidly without having to recompile the whole material every time. And that'll help when we want to make effects on the blocks like matched colors and translucent or emissive for when they get matched and when they get destroyed. But we'll get into that later in the course. I just called it a course, which is a bit presumptuous of me. So let's go ahead and go back to the file viewer here, the content browser, and just duplicate this and call it block color 1. And this will be the silver color, which I will create by just making a sort of off-white gray. We'll see how that looks. Should be fine for now. Now let's go to the construction script. Let's make a new variable on the block blueprint and call it, now there's multiple ways we could do this. I'm just going to say my color, or let's say there's only ever going to be 2 colors, so there's no reason to not use a Boolean. So we could just say is, or B is color 0, which will be true if it's color 0 and 1. Oh, that's backwards logic. Let's say is color 1. So it's true if color 1 and 0 if color 0. Hopefully that makes sense why I'm choosing to do that. It could be an enum, or it could be an int, or it could be an array of 2 colors, like an array of 2 materials even. It's not a bad idea, but for now I'm just going to do a Boolean. We can fix that up later if it seems more elegant in the future. But if you hold the B key down on the keyboard and left click, you create a branch. So I'm going to, and a branch is like a basic if statement in Blueprint. So there we go. Let's say if color is 1, then we will set the color to color 1. Otherwise we'll set it to color 0. So let's left click the block mesh and take it down in here. And so let's drag out from here and type set material, and we will just drag out the execution pin. I like to make these weird like symmetric layouts and copy paste that. The target is the same, the mesh itself. I'm getting really in depth about how I'm laying out this symmetrical layout, but it's really unnecessary. Just use the nodes like this. Color 1 or color 0. And we need to make sure this property is exposed on spawn and also instance editable, or public. The same click here makes it public or private. If you make it public and it's missing a tooltip, this will be yellow instead of green. I believe we might as well have a tooltip here. Set on spawn decides which color this block must match with to be cleared from the game. That's a really bad description. I'm just gonna do that. Is that any good? I don't know.